Okay, so my name is Kurt Grimm. My brother Ted and I own NutraDrip Irrigation. This is home for us, our family farm right here. For those of you that are here and are local, probably know all that, but appreciate everybody coming. We have both drip irrigation and pivot irrigation here on our farm. So some of the things we talk about today will definitely apply to both. Just a little bit about kind of our company, our team. Want to introduce a few of our team players that are here today and kind of where we're at. This is kind of our map, and we haven't updated it yet for this year, but this is kind of where we're doing work at. So about 50% of our business is in Kansas and Nebraska, and then the rest of it is spread out kind of all throughout the Midwest. So our growth has been good. We've added a lot of team members, and I want to introduce a few of those here this morning that are in the room. Tim Wolf, where's Tim at? Here he is. So Tim joined our team. Tim was with Netafim for 10, 15 years. He's now a NutraDrip team member, so glad to have him on our team. He's leading our agronomy charge. You shut the air compressor off. So Tim's leading the agronomy team. Cortland Byer, is Cortland in here at the moment? He'll be in wandering around a little bit later. He takes care of all of our water quality things. So things related to acidizing systems, treating bad water. That's kind of Cortland's sweet spot. Nathan Hernicek joined our team here a couple months ago as our director of sales. So he's leading our sales team. Joel Schesser, where's Joel at? Probably most of you know Joel, but Joel is leading all of the service team. So any service calls, for the most part, go through Joel. We got our Nebraska guys with us here today. Derek is in the back there, and he leads the service team in Nebraska out in Hastings, and then Trevor leads our sales effort out of the Hastings office as well. So we have two physical locations, one here in Hiawatha and one in Hastings, Nebraska. Ted does all the invoicing, operations, logistics. Tammy, which I think Tammy's back there in the back, just moved from the Grimm's Garden side over to the NutraDrip side doing sales admin. Seth does all of our estimating and our audio video for meetings. My wife Hannah, where'd she go? There she is in the purple shirt. She leads our marketing team and does a lot of the work related to marketing. Trent Strom is from Sabetha, does a lot of the sales in this geography. So I'm trying to back away from direct sales with customers and spend more of my time on business development and research and new ideas. So Trent's kind of, for my footprint that I used to do a lot of sales in, Trent's trying to pick that up for me. Brett Dick Wolf, right back here in the back, is leading our moisture probes. So anything related to moisture probes, Brett is the probe expert. So hit him up today if you've got any question on soil moisture probes. Pierre's joined our team in September. He's from South Africa originally, has an irrigation and agronomy background. We currently have him kind of focusing on ear watch, which we're going to talk about just a little bit. But he's a wealth of knowledge. He managed a large citrus farm in South Africa, had an irrigation company over there, so has a lot of experience. Deecha's not with us here this morning. He'll be here this afternoon, but he's leading a lot of training and our service and install guys out in the field. And then Davey Rock with Netafim. Davey's not in here at the moment. He's around here. So Davey is our Netafim rep for our territory. So if you got any questions, want better pricing on materials, get with Davey and tell him he needs to lower the price. So we do have he just did send an email this morning and told us that we have a fall promotion. So anybody that's interested in new drip irrigation systems, there will be a fall promotion going on this fall related to new installations. So I want to kind of go through just a few things, just spend a few minutes going on kind of what's new. We're not going to spend a lot of time today talking about drip systems so much. We're going to talk more about agronomy, what are different products that are working. And what I want to start with is just painting the picture of what is possible when water and nutrients are managed together. This is a research farm out in Atlanta, Indiana that we put a drip system in the fall of 2018. They had been raising 300 bushel grain. Sonny, this is on the Beck's research farm. Sonny Beck said, I want to grow 400 bushel corn before I die. And within 3 years, they had a wind event in 2019, but by 2020, they hit 406 bushel. We were up at the Beck's Field Day in Goner, Nebraska earlier this week, and Sonny Beck was there, and I asked him how it looked. He said he's pretty sure he's going to hit 400 bushel again. So just the idea, when we combine water and nutrient management, and we do that right, there is so much potential out there. So I think those are the things that we're trying to help our growers figure out. We're trying to figure it out here on our own farm. We've certainly never hit these numbers on our own farm yet. We keep trying. We're not going to give up. I will tell you that heavy clay soils are the hardest to work with. And so we were on, Wednesday this week, we spent the day with Neil Kinsey in Mexico, Missouri, and he spent 5 hours talking about one nutrient, and that nutrient was calcium. And just, it kind of made me back up a little bit and think about, we spend so much time and energy on nitrogen, phosphorus, potassium, and we don't give that much thought to calcium. And so I think as we think about the whole agronomic picture and how do we impact soils, that top 12 inches of soil, I'll just give you one example. So 0 to 6 inch soil sample, right? We send that into the lab. We get our base saturations looking good. We've got our calcium magnesium ratio where we want it. The last few years, we've started sampling the base saturation of 6 to 12. And our base saturations on our soils around here are around 45 to 50% calcium, 20 to 25% magnesium, and the pH is about 5. But yet that's where most of our roots are at. We do this 0 to 6 sample and we think we're good. But what about what's underneath there? Especially with subsurface drip irrigation, we're putting a lot of nutrients into that subsoil, and we've got a pH of 5 and a base saturation of 50. It's just some of the things we're not getting a response out of like we want to. So there's a lot of theories about how do we fix that, how do we address that. But those are the things that we're thinking about as we're trying to get these kind of levels on our soil and everybody's soil. There's no reason we can't do it. We have the sunlight, we have the water. Just how do we get the rest of it right? Try it for me. There we go. We're doing a lot of work with universities. The University of Illinois has an abundance of research that's been done by Dr. Fred Below on subsurface drip irrigation. They've got a whole website devoted to it, or quite a few pages. K-State has a website devoted to SDI research. Dr. Freddie Lamb, who passed away here a year ago or 2 years ago, led most of that research, but there's a wealth of information out there in some of the universities. University of Nebraska has several drip systems that we work with them on, and just within the last year or 2 years now, we've been working with the University of Purdue extensively, both on corn and soybeans. So a lot of research that NutraDrip and NetFM are doing with different universities, and excited about some of the things we're learning with those guys. I want to touch on just a couple tools that we're using that are new. We talked about them a little bit last year, but I want to touch just briefly on them again here. The thermal satellite is called EarWatch that Pierre's kind of leading the effort on. I'll just spend a couple minutes on it. So basically what it is, it's a satellite that flies over every day, and between noon and 2 p.m., they're taking a temperature of the field. And they measure soil temperature, canopy temperature, and air temperature. And with those three indicators, they're able to model and map out what's going on in your field. This was last year out here on this drip field right behind us here on the hill. June 23rd, 24th, and 25th, you could see this zone was dry. Zone number 3 had not ran. 24th, we turned that zone on, and then by the 25th, it kind of evened up. So the way we're using this is to help us manage water on a large area. We're using soil moisture probes. Soil moisture probes are still a necessary tool, but how do we take, for example, we have a soil moisture probe that sits right here, and it's looking at that 2 foot area of soil. What about the rest of the field? How does that moisture probe relate to the rest of that crop canopy throughout that field? So we're pretty excited about this tool. I think we've got around 10,000 acres signed up with it. We're using it on center pivots and drip. It really helps us understand how much water the plant is using. There's a whole bunch of different layers to this. We can look at evapotranspiration, what the actual ET is that's being measured off of the field. A lot of the evapotranspiration tools are calculations and estimates, whereas this one is more actually measuring based on biomass, what the temperature is. They're able to give us a real good evapotranspiration measurement. They do give what's called a virtual soil moisture probe. It's definitely not as accurate as a physical probe, but it at least gives us an idea. Am I saturated and really wet, or am I on the dry side? We have fields that we have quite a few fields. We have both moisture probes and ERWatch on, and so we're kind of watching those this year to see how they relate to each other. I'll talk just a little bit about soil moisture probes. Again, Brett is leading that for us, so I'll just kind of quickly go over what we're doing with those. So if you're not familiar with probes, it's basically going in the ground 4 foot. There's a sensor every 4 to 6 inches, and we're measuring the moisture level at all of those points. We can watch what the plant is doing. So we can see the plant drinks during the day, it rests at night. It drinks during the day, it rests at night. And then we can see when we water. In addition, we can see what the root depth is. So we can see early in the season, the roots are hitting that top sensor. As the roots go deeper, we can see it start drawing moisture the deeper it goes. So soil moisture probes are a super important tool to help us understand what is our moisture reservoir in our soil. How much water is in that top 3 to 4 feet, and how much of it is our plant using, and what does that look like over time? What's unique about the Grow Guru system that we're using is most moisture probes in the past, we would have to go put them out in the spring or after you planted, and then we had to take them out in the fall. And what Grow Guru did differently is they basically have an underground component that is permanently buried with a permanent battery. The battery lasts for 7 years. And then there's an above ground component that sits over off to the side, and they have a magnetic transmission that goes between here, so there's no wires. So when you come to plant or harvest, you move this top piece, move it off to the side, plant across it, then set it back, but we never disturb this probe. And so that probe is in the ground for 7 years, and we get 7 years of data. So instead of having a probe in the ground for 2 or 3 months, and all we see is that 2 or 3 month window, which is important, now we get to see what does that look like over a long period of time. So for example, if you look at this particular graph here, if we just had a probe in during the growing season, all we would see is what it's showing here. We'd see this corn season, this soybean season, but what happened in between there? And so what we've learned now with permanent soil moisture probes is what does that off-season moisture look like, and how full is my profile going into the growing season, which is super important. So lots of different things we can learn on this. The idea that we can have a permanent probe versus a probe we're taking in and out is really the key here. And it's given us what we feel like is a lot more value. We've talked about this a little bit in the past. The NutraSense is a nitrogen and potassium sensor that gets buried in the ground. So now this is a technology out of Europe. We had one of these 2 years ago. This year we have 4 of them out, and they're basically measuring the nitrate and potassium in the soil. So similar to a soil moisture probe, we're getting a physical reading of those ions. So this is what it looks like. This is the graph you get back. It's obviously a lot more messy than a soil moisture probe, but I'll just kind of give you real quick some of the summary of what we learned on our farm back. This would have been 2 years ago. So if you look at potassium level, this was on corn late in the season. So here's August. Look at what our potassium level did late in the season as that grain was the grain was filling. We did not maintain near enough potassium in the soil, which our tissue samples that we've been doing would agree with that. The one that kind of alarmed us though was look at what our nitrate did. Our nitrate was going up at the same time the potassium was going down. So just trying to understand how does nitrogen management impact the efficiency that we're getting those nutrients back out of the soil, and are we over applying? Are we putting it on at the wrong time, in the wrong form, and we're not being near as efficient as we should be? Especially for growers in Nebraska, in certain parts of the country, nitrogen regulations are already in place in some places, and they're probably going to come for the rest of us as well. especially where guys have high nitrating groundwater. It's a really, really big issue in Nebraska. So this is one of the tools that we're kind of in progress of helping get to the U.S. and help evaluate. The 4 that we installed this year are all at the University of Nebraska on some research plots. So excited to be working with them and see what we can learn. I'll touch just a little bit on automation on drip systems. So where we were 5 years ago versus where we are today, there's a lot more tools out there that help us manage a subsurface drip irrigation system and be able to see more parameters online. So this is a dashboard, but what I wanted to show here, the next slide, is what is the drip system doing over time? So everybody always asks, how do I know my drip system's working? And the answer to that question is if your flow and pressure are right. The flow and pressure are the 2 parameters that we have to monitor continually to know if the drip system is working. And so, for example, this is a graph of a drip system. You can see his pressure going in and out of his filters. You can see something happened right here, and his filters were plugged up for a little bit. This particular system is down in Kentucky on a food waste digester, so he's injecting food waste digestate into water. It's really dirty material, so his filters sometimes will flush a lot, but that's just the way it's set up. So there's a lot of new tools out there related to monitoring a drip system to make them work and make sure they're working better. We have a couple guys, like right now during the irrigation season, that check these controllers every single day. So they're going out, or they're sitting in the office and they're looking at, I think we've got a list of 50 controllers that they look at and monitor these parameters to make sure everything's working like it's supposed to during the season. Touch just a little bit on water quality. Over the past few years, we've done a lot of work on making sure that water is as effective as it should be, and we've learned that it's not. I didn't put the slides in here, but just a couple years ago, it's been 2020, we had near perfect rainfall, and we had a field where the corner of the pivot out-yielded the pivot by 29 bushel. And so it kind of led us down this path of what's in our water that's creating this kind of condition. And so one of the things we've identified is that there are high bicarbonates in water that tie up nutrients in the soil. Okay, they offset nutrients. The way that we fix that is by either acid or sulfur burners or some kind of parameter to bring that bicarbonate down. And so one of the things that we've been working with now for about a year is a company called ICL that has a dry acid-based fertilizer. So acids are not that fun to work with by and large. They're dangerous, they're a hazardous material, you got to wear all kinds of PPE. And so we've been looking at what are other forms of acid that we can get that are safer, easier to work with, and be a crop nutrient. Okay, so if we can think about how do we fertigate or fertilize our crop at the same time as we're adjusting our water pH and correcting our bicarbonate problem. And so the ICL stuff that Jason's going to talk about is one of those solutions, and I'll let him get into detail on that. The other one we're working on is sulfuric acid that is reacted with urea, and that's actually what Cortland's working on the other side of the shop. He's in the process of making a batch. The sulfuric acid, basically what you do is you take sulfuric acid and you put half water, half sulfuric acid, and then you put dry urea into that, and it melts. It basically melts the urea, and what you're left with is a 15-000-16. So you got 15% nitrogen, 16% sulfur. That product is safe and easy to work with, and it's a great sulfur source, it's a great nitrogen source. It will clean the drip line, and it treats bicarbonates. And so for guys with center pivots, it would treat your bicarbonate issue. Guys with drip systems, it would clean your drip system. And so what we're trying to put in place for next year is to have fertilizer options where you're buying acid-based fertilizers that treat your water, clean your drip system, and are used for more than just a line cleaner. So it basically becomes part of your fertilizer budget that you're reallocating. So instead of spending more dollars, let's spend those dollars and make sure that product does two things versus just a nitrogen source. The other note I wanted to make is that we've got over here on the trailer that blue solubilizer. Take a look at that today. What that is it's a unit we bought from a company out in Utah, where basically you put dry fertilizer in the top of there, and there's a wobbler in the bottom of it, and you can put any kind of dry fertilizer in there, and it will slowly dissolve it and inject it into an irrigation system. So one of the things we did this year is we got in a semi-load of gypsum. So we actually injected gypsum through a drip system and through some of our center pivots, trying to get our calcium levels up in the soil during the irrigation season. We also ran some AMS in there. We could run calcium chloride. We could run any of the ICL products through that, because that's one of the challenges of a lot of these dry products is you bring them in and then you got to get them into solution. So that machine, I think we're going to be using more of those going forward. So if you have time, take a look at that if you're interested in solubilizing fertilizers. I'll touch just a little bit on some of the things we're doing with manure. So over the past 5 or 6 years, we've been working with quite a few livestock producers, separating liquids from solids and then injecting that liquid portion into a drip system. So there's 2 pieces of equipment, and I've actually got the trailer sitting outside here today, so when you step out the door, you can smell it and see it. It's not the prettiest thing. We didn't clean it up very well. So it's not a showpiece. It's an actual working piece of equipment. But basically what it is, there's a screw press on the front that separates the big particles. And then this microfilter has a 25 micron screen that takes out all the small particles. So the liquid coming out of this microfilter then is clean enough to go to a drip irrigation system. So this is a video of the microfilter working on a dairy, a couple of them. And this particular dairy up in Minnesota, I think we've separated about 3 million gallons this year and ran it all through subsurface drip. So pretty excited about what we're doing with this. We've done several 100,000 gallons of hog manure out of a deep pit confinement barn as well up in Iowa. So this is something that we're putting a lot of energy into and continues to work. This is the trailer that's sitting outside. That we kind of move it around, use it as a demo machine and a test machine. There's been a lot of work gone into getting that set up and getting it working. For guys that have lagoons, it's a lot simpler. So basically what we're doing is we have a river screen system, and there's a new test unit sitting over here on the floor that we're going to be testing as well. But basically what this is, there's 120 mesh, I need to change that slide. It's 120 mesh drum on here, and it leaves the liquids in the lagoon, and we're just taking the water out. So Todd Roke's here. He's been doing this on his hog barn here for what, 3 or 4 or 5 years now, 4 years. It's been working really well. This is a lot simpler, less expensive. It's a really simple system, and we're injecting hog manure this way as well. We're also doing some work with pits where we've taken drip line on a new hog barn, a new hog confinement barn, and we attached an air line to the bottom of the pit before they put livestock in it, and we're bubbling air through there. So basically, we've got this barn. The first barn we did, I think, was 17 zones. So each one of those zones runs for 2 minutes every hour, and it just bubbles that air through the manure. A couple things it's done. So this red line, we have an ammonium sensor in a barn that does not have pit irrigation. You can see that ammonium level was anywhere from 35 to about the low of about 7.5. The barn with pit aeration, we've almost eliminated the ammonia smell. So when you walk in the barn, that ammonia smell that burns your nose, we've almost eliminated that. And the reason that is because anaerobic pits, they're anaerobic. They give off methane, hydrogen sulfide, and ammonia. And so when you keep it just slightly aerobic and you're turning it all the time, instead of that nitrogen leaving the air and ammonia, it stays in the manure. So we potentially will have higher nitrogen values. We haven't seen that yet. We don't have enough data yet. We've only been doing this for about a year. So we've got a lot of interest in that. We think that's going to be an interesting product going forward. We haven't figured out how to do it on existing barns yet, so you have to get your pit clean in order for us to put it in, but we're certainly open to that idea. So, okay, that's kind of the what's new. So I'm going to turn it over to Jason with ICL. Jason is from Illinois,